Hello, hi, guys. Hello, hi, everyone. Today, first of all, welcome to this session. Today, we are looking about the event loop. What is the event loop? And we will dive into the event loop, and I will make you much more understandable and which you never forget. Let me share my screen first of all. Yeah, I hope my screen is visible to you, all of you. So, first of all, let's see introduction of the event loop. What is the event loop and learn why we should learn event loop? JavaScript is one of the most powerful language in this today world. It runs everywhere. It handles user interactions, animations, network call, and much more thing. But here is the interesting part. JavaScript can do only one thing at a time. So how does it handle the many things without freezing? This is the questions here, right? What is the magic of the event loop and the engine that makes JavaScript feel smooth, fast, and intelligent? Today, I'll teach you in a way that have complete beginning will understand. So as you can see here, this is our JavaScript environment, right? So this is the Java. So we are having a JS environment. हमारे पास एक JavaScript engine होता है which we call JS engine, and also this is the whole JavaScript browser environment. Okay, so inside the JavaScript environment, JavaScript would run inside the JS engine, right? So inside the JS engine, we having the call stack where all code are executed, right? Also, we are having a web APIs, right? And to communicate outside of the world. And JavaScript is a single threaded language, right? Let's imagine JavaScript is as a person who perform tasks one by one, right? Let's consider JavaScript is a person, JavaScript as a person. Let's consider JavaScript as a person and who perform a task one by one. And they read one line of the code and finish it, then move to the next line. JavaScript cannot do task at the same time. Inside its main executions called this is called single threaded executions. It sounds simple but become complex when we deal with the task like timer or network call. Imagine the problem, the main problem, what if something takes time? What is the problem? What if what the problem? What if something takes time? Imagine JavaScript encounter a very slow task, a loop that run a billions times a or timers or network request waiting for data. If JavaScript wait here, the user cannot click and UI get stuck. Website also get freezed, right? This is why we need a different system. A system that allows JavaScript to continue working while slow tasks are handled somewhere else. तो जैसे कि हमारे पास जावास्क्रिप्ट एनकाउंटर होता है उसी हिसाब in similar fashions we should having something to handle these kind of stuff, right? That's secret helper behind the JavaScript web API. So here we are having some secret feature which is provided by the JavaScript. JavaScript is not alone basically. JavaScript अकेला नहीं है. It lived inside the browser. It lives inside the browser and browser gives JavaScript to superpower. Browser JavaScript को super power देता है. These powers named called web APIs. Set interval, fetch DOM, event, and local storage. And when JSC slow task does something brilliant, It gives the task to the browser and JS continue running other code. Browser complete the task and notify JS later a non-blocking. Call stack, the heart of JavaScript basically. Let's understand the call stack. The call stack is the place where JavaScript actually execute code. Think of it like a stack of a plate. Think of it like a stack of the plates. We when functions called, right? When functions we called, it placed to the top of the finished. It is placed on the top. When finished, it is removed. JavaScript always work on the topmost plate. If something heavy sits here, everything else behind it must wait. Let's see the code example and normal synchronous flow. Suppose that this is the functions that I have declared and this is the another functions. And if we call these functions, first A functions will be called and that functions will be pushed into the call stack. Then B functions we called that again the functions will be uh, pushed into that things and then we execute this code console.log and then again simple sequence and everything will be executed one by one, right? Web APIs handling web APIs handling slow work for JavaScript. When JS sees this, right, this is the set timeout and it does not wait for 3 seconds. As we have mentioned, this is the set timeout. Set timeout is the web API. It takes a functions callback. It takes callback functions, which is delaying 3 seconds. It does not wait for 3 seconds. Instead of that, timer goes to the web APIs and web APIs continues JS running and next code after 3 seconds, browser send a message back to JS, but the message cannot interrupt JS directly. So where does it go? It goes in where it is go? It goes in callback queue. Once the browser finishes task and set time out and set interval, click event, it put their callback into the waiting areas called callback queue and also called as a microtask queue. These tasks wait patiently and for their run. Let's understand the microtask queue. Some tasks are more important, right? The promise.dan and async wait and queue microtask. These go into the BIP, special BIP queue called the microtask queue. JavaScript always clear these questions first because microtasks have a higher priority. Suppose this thing we are having this call stack and also we are having a web APIs and also we are having here event loop. For an example, one we are having a functions which is the set time out functions. The set time out functions callback inside the set time out we are having a callback functions. It will be registered into the web APIs. Callback function will register and timer will run till the time. Once timer will complete, this callback functions goes into the micro task queue or callback queue. Okay, and fetch is the functions and which having a higher priority and basically related to the promise. These things will push into the micro task queue. Then event loop is the hero of this picture. Event loop continuously checked both. First, it will check the micro task queue whether micro task queue has a callback queue, has the callback functions or not. If macrotask has no callback functions callback, then it will check the microtask queue, and from that also that push into the call stack, and once that has been executed, it go to the another callback queue, and again it will run till until the callback functions having uh, like until we are having it will run until जब तक हमारे पास functions registered रहेंगे, it will run until that time. So once code will be executed, right? Let's code example microtask versus and console dot start and set timeout and promise dot resolve and console dot promise and this. Yeah, console dot log, and it will be start, right? And start and set timeout console dot log timeout. This is the timer functions as we know. This is our timer functions as we know. So what will happen here? The timer will be timer will not run directly. So let's see how this code will be executed for the microtask queue. Suppose that this is the our JavaScript code. So once JavaScript engine see the JavaScript code, it runs the code line by line. Okay. Console.log, it will be pushed into the call stack and it will run quickly. It will run quickly and the start will be print. Set timeout. Here is set timeout is the Web API. So Web API is not run directly. So it's a Web API. So it will be, it is set timeout is the web part of the Web APIs. It having a callback functions which delay 0 seconds. So it will be the callback functions will be registered into the Web API environment. Once 0 second timer has been passed, then this callback functions will be pushed into the callback queue. And this is the here promises which we are having. So promise dot resolve and dot then promise dot resolve and dot then and console dot log promises. So these things, this callback functions will be registered, and the it will be pushed into the microtask queue. So like as we know, it microtask having a higher priority. So after that, before this line of the code promises will be run, then here timeout will run. Now comes the hero of the story. Now, the event loop. So now comes the hero of the story, the event loop, the event loop. Now, event loop. The event loop is the one of the most important idea in JavaScript. If the call stack is the heart, the event loop is the brain that decide when things should be happen. Now the comes the hero of the story and the event loop. The event loop is the one of the most important idea of the JavaScript. If call stack is the heart of the JavaScript, then event loop is the brain of the brain that decide when things should be happen, when things should be happen. And you can think of event loop. You can think of event loop as a messenger or as a manager. You can think of event loop as a manager and who consistently watch the system and makes decision every single moment. Here is how work in simple word. The event loop keep watching the call stack. Event loop keep watching the call stack, and it looks the call stack again and again and asking in JavaScript, and is JavaScript busy right now or it's free? If call stack is busy running some code, the event loop patiently wait. And then JavaScript code, when JavaScript become free, when JavaScript engine become free, It gives first priority to microtask queue. The event loop says, before anything else, let me finish all the tasks, all the microtask promises. These are the BIP tasks. So it runs every single promise callback one after another until the microtask queue is complete empty. This is why promises run earlier than timeout. The after microtask, it run one microtask. When microtask queue is empty, the event loop run the callback queue and says, okay, now I can take a normal callback like set timeout or click event. I'll take only one microtask at a time, run it completely and repeat the whole checking process again and again. This cycle repeat over this checking, deciding and executing happen so fast that it seems magical, but it just event doing its job perfectly. This is what keeps JavaScript smooth, faster, responsive, non-blocking, and able to manage multitask even though it has only one threaded. Why promise chain run faster? Let's see. Promise.resolve and then console.c console.d. Both C and D go into the microtask queue. This means they run before timer callback. This is why A, E, C, D, P. Set timeout is not instant. A timer with the 0 minute second still goes to the callback queue, so it must wait for the callback, the call stack to be to empty. Microtask to complete this complete map. And this is why I feel slower than expected. Full analogy and supermarket. Like let's imagine the full analogy of the supermarket. Uh, Cashier JavaScript worker APIs. Let's remove it. See, final summary of crystal clear. JavaScript run thing at a time, one thing at a time. Browser handles slow tasks and microtask and event callback queue and priority queue. This comprehensive diagram shows all component working together. Call stack yellow. This is the call stack. No, let's see this. That's this code. Let's understand this code finally. Console.log is one, right? And set timeout, this is the timer functions. And again, this run after the 1 millisecond. Promise.resolve, it will be run before the set timeout. And console.log and console.log1, it will run quickly. And now the times up to the this console3, and this is the you are absolutely right. So thank you so much for attending these sessions. I hope I will be able to clear your about the event loop. Thank you so much for joining us.